at the convex mirrors like we did the concave mirrors yesterday. These are going to be very similar, but instead of the rays converging, when I have rays coming in parallel, they end up diverging, moving away from each other. So we still have this principal axis, but in this case, the focus is behind the mirror. Our diagrams are going to be done just like we did the converging lens, the concave one. They're just going to look a little bit different, but the rules are still going to be the same. So if we have here's my principal axis. The focus and the center, again, are behind the mirror this time. I'm just going to draw a random object. Again, this is free-handed. It's not going to come out perfect, but you'll get the idea. And again, it's the same thing that we did with the other type of mirror. Again, we're going to draw our incident rays in red. We're going to go in parallel to the principal axis. But then when we go out through the focus is on the opposite side of the mirror. So I need to line my ruler up with the focus and where the ray comes in contact with the mirror. And I'm going to dot it behind the mirror because it's not really there. So in reality, the ray comes in and bounces out like that, but I'm using the dotted line to show that it's lined up with the focus. So in parallel, out through the focus, in through the focus. So again, I'm going to line up the head with the focus. I'm going to go in solid until I reach the mirror, and then I'm going to dot behind, just showing that I'm lined up with the focus. So in through the focus, out parallel to the principal axis, and since these rays are going away from each other, we know they're never going to meet, so we're going to end up dotting our line behind the mirror. And then the last line is in through the center, out through the center. So in through the center, again, I'm going to dot this behind the mirror to show that I lined it up with the center. Out through the center would look the same, dotting it behind the mirror, going out there. So notice all three of the lines come together, they meet, they intersect behind the mirror. The dotted lines are intersecting, so that would be a virtual image. So that's the image of the head. So this arrow here, where those three orange lines intersect, is the image. Because it's dotted lines that are intersecting, it is a virtual image. The light isn't actually here, it just seems like it's coming from there. Size, it's reduced, it's smaller than my object was, and it is upright. Alright, and then for seeing it, I'm going to put my eye somewhere, it doesn't really matter where that eye is too much. And then we go in green. We're going from the eye to the tail of the image, and I'm going to dot just to show that that line was lined up with the tail of the image. And then from the tail of the image, but where it's intersecting the mirror, that came from the tail of the object. So we have this ray going from the tail of the object to the mirror and bouncing off to the eye. And then from the eye to the head of the image, since that's the ray that sees the head of the image, it must have come from the head of the object. So we can see that from this little portion of mirror, we are able to see the image of that object in this mirror. The equations are going to be the same that you're using for the converging mirror as well. So you can work on those equations as well as the ray diagrams. Again, remember, each group needs to have one complete set of ray diagrams for each of the types of mirrors. Not every person needs to do each of these. They're going to be very, very similar and repetitive, so make sure that you as a group have looked over all of them. But I'm not going to make everyone redraw every single one.